Good afternoon, everyone. My name is Janice Connell, and these are the results of my Lab 1 experiments. In the Lab 1, we were to set up an experiment to observe constant momentum. We were to use Tracker to analyze the video and plot the positions over time, write a computer program to predict movement given the velocity and time changes, compare the observed results to the model results, and draw conclusions. In my case, my hypothesis is, and this is the setup for my experiment, is that if I have a tennis ball rolling across a countertop and it has a constant velocity, then position over time will be a linear line. So let's go to Tracker to see my video. Here we have the tennis ball going across the counter, and you can see the line graph is linear. You can see my time and x-axis data, and I'm going to take that and put it into my data. So my observations were my initial starting time was 0, initial position, and my last observation time was 0.96647 seconds. From that data, in the individual observations, I can calculate my initial velocity, and it was 0.53027 meters per second. Then I went into the program that we were given, and I input the relevant data. I have the ball position, the ball mass. Look that up from the internet. My starting vector, my velocity vector, and my time observations are 30 frames per second, and go through the while loop there, gather my data, and put that here. And then I modeled the two lines. And you can see that the model line is, of course, linear because we assume constant velocity. In reality, you can see that the velocity is slightly decreasing. My conclusion is that the observation was position over time was not linear, and that my conclusion is that Newton's second law is in action, and that there is another force acting on the ball. In this case, it's probably friction. If I had used, for example, a cue ball, there would be very little friction, and I probably would have had much more of a constant velocity linear line. So my next step would be to try and model the force that is in action on the tennis ball. Thank you.